Welcome everyone. In this video, we will introduce our system DBMind, a self-driving database platform, and we use the transaction business in banks as an example to demonstrate our system. Managing multiple database instances is critical in many application scenarios like banking, insurance, and e-commerce. However, manual methods cannot satisfy the requirements of the rapidly growing users, data, and workload, and it is challenging to automate the management procedure. First, to detect anomalies, we need to monitor hundreds of system metrics around CPU, I/O, memory usage, and others. Second, we need to diagnose root causes. And based on the causes, we need to optimize different modules in consideration of the performance, cost, and overhead. To address these challenges, we present a self-driving database platform, DBMind, which integrates machine learning models and expert knowledge to resolve database problems. The self-monitoring module monitors and collects the information of database instances like OS, status, and log alarm metrics. The self-diagnosis module trains an LSTM model to learn the root causes from both abnormal and normal data. And the self-optimization module utilizes the learning-based methods to optimize the databases, like the reinforcement learning for knob tuning and the deep tree search for query rewrite. Next, we use a banking scenario to demonstrate our system. The service is supported by 10 instances, where the peak concurrency is about 10,000 queries per second. After logging in the system, we can see the monitoring module dynamically presents abnormal metrics that can reflect database problems. For example, DB read gets relatively high when there is a I/O situation. Meanwhile, DBMind scores the database based on the potential risks in configuration, resource, and others. For the identified anomalies, DBMind automatically evaluates the risk level, diagnoses the root cause, and gives the optimization suggestions. For example, half a minute ago, there was a middle risk anomaly. It was a workload peak caused by bad knobs. We can click the knob tuner button, and the pop-up page shows the recommended knob settings. If the knob settings pass checking, we can click Apply to replace the current database knob settings for higher performance. Besides, we can see there was a slow query anomaly, and DBMind caused the query toolbox to conduct an all-around optimization. First, it provides a runtime status of the query like query execution time and affected rows. Second, it diagnoses abnormal operators, like the gather operator that takes 99.8% of the total execution time. Based on the problem, it utilizes 3 optimization modules to speed up the slow query. In query rewrite, it shows a rewritten SQL statement. Compared with the original SQL, it has removed redundant operators and optimizes the logical query structures. In Index Advisor, it advises to create index that can enhance query execution within resource budget. And finally, in the plan hinter, it reorders the join operators and gives the optimal physical execution plan after applying all the optimization actions within 0.3 seconds. The performance of the query has been improved by over 60%. Lastly, to simplify usage, DBMind lists the optimization tools in the left column. DBMind logs slow queries while the database running. We can browse them and choose any query we want to optimize. This way, we have built a self-driving database platform that achieves self-monitoring, diagnosis, and optimization.